Welcome to Organic Chemistry, Lesson 11. Now we're going to talk about addition reactions. In addition reactions, two or more reactants combine to form one product. So if you have A and B, they are combined to form C. Addition reactions are for unsaturated compounds. Therefore, alkenes and alkynes can undergo addition reactions. The first type of addition reaction is hydrogenation. In hydrogenation, we are adding hydrogen to an alkene. Here you have an alkene because there's a double bond. Now you are adding hydrogen, which means a hydrogen atom bonded to another hydrogen atom. Now I call addition reactions also Christmas reactions. Why? Because each double bond carbon gets another atom. So it's like Christmas. Everyone gets a present. The blue double bond carbon gets the blue hydrogen, and the pink double bond carbon gets the pink hydrogen, and then you have an alkane at the end. The reaction conditions. You need a catalyst for this reaction to occur, and the catalyst can be palladium or platinum or nickel. It requires heating and an inert atmosphere. The second type of addition reactions is halogenation. We are adding a halogen to an alkene. The halogen can either be chlorine or bromine. For this example, we are using bromine. Now you have an alkene here. You have a blue double bond carbon and a pink double bond carbon. You have a blue bromine and a pink bromine. And now, because it's Christmas reactions, the blue double bond carbon gets the blue bromine and the pink double bond carbon gets the pink bromine. And there you have your product. Now this can also occur for chlorine. Here again you have a blue double bond carbon and a pink double bond carbon. The blue one gets the blue chlorine, the pink one gets the pink chlorine. And there you have your product, addition. Your third addition reaction is hydrohalogenation. Here we are adding a hydrogen and a halogen. That can be hydrogen chloride or hydrogen bromide to an alkene, of course. Now in this case, you again have a blue double bond carbon and a pink double bond carbon. Now you have a blue hydrogen and a pink bromine atom. Now remember, each double bond carbon gets its own atom. This is Christmas, so the one cannot get two atoms, each one gets one atom. The blue carbon gets the blue hydrogen and the pink carbon gets the pink bromine atom. Now it can also be turned around. If the blue carbon gets the pink bromine and the pink carbon gets the blue hydrogen, you have the same product, so it doesn't make a difference. But this will not always be the case. The reason why in this case it's the same is because this is a symmetrical molecule, which means the left-hand side of the double bond looks the same as the right-hand side. Here, you do not have a symmetrical molecule. The left-hand side of the molecule looks different from the right-hand side of the molecule. Or you can also look at the blue double bond carbon, which is bonded to different atoms than the pink double bond carbon. Now let's for instance say that the blue double bond carbon gets the blue chlorine and the pink double bond carbon gets the pink hydrogen. Then this will be your product. This we call the major product. The product that is the most likely to form, the most stable product. And we have a rule to identify it. If we turn it around and the pink hydrogen goes to the blue double bond carbon and the blue chlorine goes to the pink double bond carbon, you form the minor product. Now the rule says that the hydrogen should always go to the double bond carbon with the most hydrogens. If you look at the pink double bond carbon, it's got 2 hydrogens. If you look at the blue double bond carbon, it's got no hydrogens. Look at what it is bonded to. A carbon, a carbon, and a carbon. Therefore, the pink hydrogen should go to the pink double bond carbon because it's got the most hydrogens to form the major product. And there you have your rule. For the major product, the carbon atom with the most hydrogens gets the hydrogen atom. Then we have your fourth and last addition reaction, hydration. Now we are adding water to an alkene. Water is a hydrogen atom and an OH group. This is also the synthesis of alcohols. Now if you look at your alkene, you have a pink double bond carbon and a blue double bond carbon. And in your water molecule, you have a blue hydrogen and a pink hydroxy group. Now the blue hydrogen goes to the blue double bond carbon and the pink hydroxy group goes to the pink double bond carbon because it's Christmas and every atom gets another atom. Your reaction conditions, it needs a catalyst, an acid. Now let's see if we turn it around. If the blue hydrogen goes to the pink double bond carbon and the pink hydroxy group goes to the blue carbon, you get another product. But these two molecules are exactly the same thing. So in this case, it doesn't matter because this is a symmetrical molecule. The left-hand side looks the same as the right-hand side. But what about this? Now you do not have a symmetrical molecule. The blue double bond carbon is bonded to different groups than the pink double bond carbon. Now, if you use your rule which says for the major product, the carbon atom with the most hydrogen atoms gets the hydrogen atom. If you now look at your double bond carbons, the blue double bond carbon has got no hydrogens. The pink double bond carbon's got 2 hydrogens. Therefore, the pink double bond carbon must get the hydrogen and the blue double bond carbon must get the hydroxy group to form your major product. And for your minor product, the blue double bond carbon will get the pink hydrogen atom and the pink double bond carbon will get the blue hydroxy group. So this is your minor product and here you have your major product according to your rule. Very important. And then for the last type of addition reaction, you have polymerization, number 5. Now polymers are made up of small units which are called monomers. So in this case you have the monomer here and then it's added together infinitely and then you form a polymer. And this process is called polymerization. Thank you.